Hey, what's up everybody? In this video, we're going to go over our first algorithmic pattern, the sliding window pattern. So what is the sliding window pattern? Well, it's important to note that we can break the sliding window pattern down into two types. One that uses a fixed window size and one that uses a dynamically sized window. The problem will determine whether or not your window size will be fixed or dynamic, which you will see examples of soon. For now, let's start with the fixed window size. Let's imagine that we have an array of integers, and then let's imagine that we want to calculate the average of the values within a specific subset of that array. For example, say we are asked to calculate the average of a contiguous subarray of size 4 within this array. Contiguous just meaning that all 4 elements are adjacent or next to one another. So for the sake of this example, we'll do these first 4 elements. First of all, since the size of the subarray is given to us, because we are asked to calculate the average of a contiguous subarray of size 4, 4 is the size of our window, of fixed size. So we would add all 4 of the elements up, and then divide the sum by 4, because to calculate the average for a set, you simply take the sum of the numbers and divide it by the total number of values in the set. Now let's imagine that we need to find the maximum average when considering all contiguous subarrays of size 4 within the array. Sounds a bit complicated, right? Well, let's break it down. How many contiguous subarrays of size 4 do we have in this array? Remember that contiguous means that all 4 elements are adjacent to one another. This tiny array is small enough for us to count these sets out. So we have a set of 4 here, here, and here. Anything beyond that is no longer a subarray of size 4. So what we want to do is calculate the average for all 3 of these subsets, and whichever has the highest average is our answer. Now there's a naive way to solve this, which we are actually going to go over step by step. This is the only time within this video that we will write code for the naive solution to a problem. This is so that you can actually feel in your soul the benefit of using the actual pattern. And by the way, the problem that we are referring to currently is this Leetcode problem here. So before we get into an example of the sliding window solution, let's go over how not to solve this problem. So the naive way to solve this problem would be to iterate through k elements for each element of our input array. So for this first element of our input array, we'd iterate through each of its elements up until k, adding them to our sum. Then after, we'd divide that sum by k. Then we'd move on to the second element of our input array. And we would once again iterate through each element up until k, adding the values to our sum and dividing that sum by k. And then once again, for our third element, we'd do the same thing. So at this point, you've probably already noticed why this is inefficient. But let's keep going. Let's write some code. Okay, so before we get started with writing up our code, you're going to want to install Go if you don't already have it installed. So to do that, you just want to go to golang.org. I'll put a link in the description. And from this page, you just want to hit download Go. And from here, you will just select the package for your operating system. I'm using Mac, so I would select this package. And from here, you will download an installer that is self-explanatory. So just download and run this installer. And once you have everything installed, the only thing that you're going to need to pay attention to at this point is your Go path. And you can see what your Go path is, as well as check to see if Go was installed correctly by just doing Go environment Go path. And here it will show your Go path. And this path is generally just going to be a Go folder within your home directory. Okay, so to start, I'm just going to create a directory in my Go path source folder, and I'm just going to call it YouTube patterns. And I'll just cd into that directory. And within this directory, I'll just create a file called bad max average subarray.go, i.go. And I'm just adding bad to the name because this is the naive solution. So we'll go ahead and open that file. And actually my Vim is complaining, so I'll just do go mod init and then just go mod tidy And then I'll go back into the file. And within this file, I'll just add a comment to the top and I'll say Leetcode problem. And we'll just take the problem number and name here and copy it, and then go ahead and paste that to the top. And just a quick note, this problem actually isn't one of the problems in our Leetcode patterns list. I'm using this problem to explain what sliding window is because it's relatively easy to understand. So what we're going to need to do is we're going to need to call this package main, and we'll go ahead and import format and math. And then we're going to create our entry point, which is just going to be a function called main. And if you're unfamiliar with Go, you should have no problem following along with this tutorial because I go pretty in depth when explaining the code. So if you're familiar with any other programming language, I think that you should be fine with following along with this tutorial, even if you don't have experience with Go. So we're going to create a variable for k, which we're going to pass into the function that we create for this problem. So the input for k is going to be 4, same as our example. And then we're also going to create an input array. And to initialize an array literal of integers in Go, we're just going to do this. And within these curly brackets, we will add the numbers from our problem in the example. So we can just take these numbers, copy them, and then paste them here as our input array values. And then we'll set our answer equal to the returned value from our function, which we will call find max average. And then of course we'll pass in nums and k. And after we get the answer, we're going to print our answer. So this is going to be our main func. So whenever we run this file, it's going to run this main function, and it's going to pass these two values into this function that we haven't yet created. So now let's create this function. So we'll do func find max average, and it's going to take in nums, which will be an array of integers. And it's going to take in k, which will be an int. It's going to return a float 64. And to start, we're going to initialize a variable called max. And its initial value is going to be -infinity. And in Go, this is how that's done. We use the math package, and we use this inf method. And the reason we want max to start off as -infinity is because if we started off as 0, which would be the default initial value, if we were to compare a maximum average that's a negative number to 0, the maximum that is returned would be 0 instead of the negative value. I hope that makes sense, and if it doesn't, it'll become more clear as we go on with writing this function. So we're going to start with a for loop. I is less than the length of nums. We're going to increment our I. So we're going to iterate through nums, which is the input array containing the integers. And for each iteration of nums, we're going to create a window sum, and we're going to set it equal to 0. And also for each iteration of I, we're going to iterate through k, just like in our example. So for j equals 0, j is less than k, j plus plus. Now, as you saw in the video, there's going to come a point where we reach the end of the array, and if we go any further, the subarray size is going to go beyond the array's size. So to solve that issue, we're going to write an if statement. If not, I plus k minus 1 greater than the length of nums minus 1, then we'll perform this code. Window sum plus equals nums I plus j. So just like in the example before of the naive solution, for each element of I, we're going to iterate up to k elements. And if this is sounding confusing right now, don't worry, I'm going to explain each line of code in detail after we finish writing this code. So just bear with me for a bit if you can't understand it. Then we'll add else. So if performing the above code in the if statement will bring us out of the range of the size of our array, then we're going to instead set our I equal to length of nums and set our j equal to k. And this is essentially just going to terminate the for loops. And following the termination of the loops, within our top level loop, we still want to check if window sum is not equal to 0. And if it's not, we're going to set our max equal to whichever is greater, our current max or the current subarray's average. So we'll do math.max, and we're going to check if max is greater or float64 window sum divided by float64k. And the reason we're converting these to floats is because they're currently integers. And if we divide an integer by an integer, the result of the division is going to be an integer as well. So if there's anything after the decimal point, it will be removed. So we're going to want the result of the division to be a float. And once we do that, outside of both of the loops, we're going to check if max equals math.inf. So if max equals -infinity, we want to return 0. We never want to return -infinity. But if that's not the case, we're just going to go ahead and return our max. And again, if any of this is confusing to you, don't worry, just bear with me. I'm going to go over it and try to help you visualize it in the next step. So we can go ahead and save this file. And let's clear. And then let's go run badmaxaverages.go. And the result we get is 12.5 as the maximum average, which if you remember from the presentation, 12.5 is the highest average. The other two averages for the other two subarrays are 10.5 and 0.5. So now I want to take some time to go over every line of code to attempt to help you visualize what's happening here. So let's do that. Okay, so now let's take some time to try and visualize how this code is working. So let's assume that we're going to be taking in the same input array nums as the one showed in the presentation example. So we're going to have 1, 12, -5, -6, 50, and 3. And let's go ahead and add the indexes as well. So we have index 0, index 1, 2, 3, 4, and 5. And k is going to be the size of the subarrays that we need to calculate the averages for. So if we were to call this function with these input parameters, we'd arrive at this line here where we initialize our max value to -infinity. And the reason we're initializing it to -infinity is because if all of the subarrays within our nums array have averages that are negative numbers, we still want to figure out which one is the maximum. And if we were to initialize this with a value like 0, which would be the default value for an integer, if all of the subarrays within nums had averages that were negative, the value that would be returned would be 0, which would be wrong. So if we're using -infinity, even if the maximum average of the subarrays within this nums array is something like -1 million, it would still be considered greater than -infinity. So following the initialization of our max variable, we would arrive at this for loop here, which is just a standard for loop that's iterating through our nums input array. And for each iteration of this for loop, we're going to do the code here. And I actually shouldn't have named this window sum because it's kind of misleading because we're not even using the sliding window technique for this naive solution. So I apologize for that. Please don't get confused. We're not using the sliding window solution yet. This is still the naive solution. So this window sum is basically representative of the sum of a particular subarray within nums. So just ignore the window part. And then we'd arrive at this nested for loop here. So let's consider that we are in the process of iterating through our input array nums. So we'll say that we're currently at index 0 of this top level for loop, and our window sum is currently set to 0. So let's write that out as well. We'll just call it WS, and maybe that's an ugly WS. Did the best I could. Okay, so we have our window sum equal to 0, and we're on the first iteration of this for loop, which is index 0. So then we'd arrive at this nested for loop here. And this for loop is going to be the loop that we're using to iterate up until k, because for each index of nums, we want to iterate up until k. So if we're at the 0th index of nums, we want to calculate the average for a subarray of size 4. So we want 1, 2, 3, 4 elements in our subarray. So we want this to be our subarray. So what this for loop is doing is we're using the variable j to iterate up until the size of k. So we're essentially going to stop iterating when j becomes equal to k. So j would start at 0, then j would become 1, then j would become 2, and then j would become 3. And once j becomes 4, j is no longer less than k, so we would no longer iterate. And that would leave us with this subarray here. So for each iteration of this inner for loop, we're going to arrive at this line of code here. And this line of code is just making sure that we don't try to calculate the average for a subarray that isn't within the range of this nums array. So for example, if we're at index 3 of this top level for loop, iterating up until the size of k would bring us here, which is out of range of this array, and the program would panic. So what this line of code here is going to do is it's going to preemptively check that the subarray will not exceed the indexes of the nums array. And I'll explain how it's going to do that now. So basically the length of nums is how many items that are in nums, right? So we have 1, 2, 3, 4, 5, 6 items in nums. And then we subtract 1 from that length. And that's going to leave us with the maximum index for the nums array. So the highest index that we can query a value for within this nums array is going to be 5. And the highest index that we can query a value for any array is going to be the length of that array minus 1, because indexes are 0 based. So if the array has 6 items, it's only going to go up to index 5 because it's going to start from 0. So for this nums array in particular, this expression here is always going to resolve to 5. So we can actually just write that here so we can kind of have a better understanding of what's happening. And the next expression that we need to pay attention to is this one here. So here, I plus k minus 1 just means that whatever index we're on, if we add k minus 1 to that index, we'll get the maximum index for a subarray of size 4. So for example, if we're on index 1 and we add k minus 1 to index 1, so if we add 3 to index 1, we're going to get index 4. And index 4 is the maximum index for this subarray of size 4. So we're checking if the index that we get as a result of calculating this expression is not greater than the maximum index of the nums array. So for this inner for loop, we're only going to continue to increment our j and add to our subarray sum if this expression here doesn't resolve to true. Because if this expression resolves to true, then it means that we've reached a case like this one here where we're at index 3, and adding k minus 1 to index 3 would give us index 6, which is out of range. This array only goes up to index 5. So if we won't exceed the length of our nums array when iterating up until k, then we can start adding to our sum. But if we will exceed the length of our nums array when iterating up until k, then we're going to go down to these 2 lines of code here, which essentially terminate both for loops. And they do that by we're setting I equal to the length of nums. And the condition for this for loop up here to run is while I is less than the length of nums. So if I is equal to the length of nums, this for loop would terminate. And the same thing with this one. We're setting j equal to k here. And the condition for this for loop to run is while j is less than k. So if j is equal to k, this for loop will be terminated as well. So let's just keep going here. So we're at index 0. Our window sum is 0. We're going to start this inner for loop. We're going to arrive at this line here. Index 0 plus 3. And let's go ahead and write this in here as well. K minus 1 is always going to be 3 for this input array. So 0 plus 3 is not greater than 5 because 0 plus 3 is 3. So we're going to go ahead and add to our window sum the value at index I plus j. And the reason we're doing the value at index I plus j is because if we're at index 0 and j is 0 as well, we're going to take this value. And then we're going to stay at index 0 for this top level loop, right? And then we're going to increment up for this inner loop, right? So this is going to become 1. So if we're at index 0 on our top level loop, and we're at index 1 for our inner loop, then 1 plus 0 is going to be equal to 1. So this is going to resolve to index 1, which is going to be this value. And the same thing for when j becomes 2. If our top level index is 0 and we add 2 to it, the index here is going to become 2. So we're going to take this value. And then lastly, the same thing for when j becomes 3. If we're at index 0 here and we add 3 to our index 0, we're going to get index 3, which is going to be this value here. And then that is our subarray. And we won't reach this case, but I'll explain it anyway. If we're at index 3 for I, you can see where things become problematic, because if we're at index 3 and j also is at index 3, which would happen because this inner for loop is going to iterate until j is equal to k, which is 4. But if it's less than k, 3 is still less than k. So if we were at index 3 and j was also at index 3, the resulting index here would be 6. And we would try to get the value at index 6 of nums, but nums only goes up to index 5. So the program would panic because we're trying to access an index of the array that doesn't exist, which is why we need this line of code up here. I hope that makes sense. This is the most difficult part of this function to understand. So let's just continue to try and step through this. So we're still at index 0, and then for our inner for loop, we're at index 0, and this expression here isn't resulting to true when we're at index 0, so we come down here, and we're going to add nums I plus j. So if I is 0 and j is 0, we're going to add nums at index 0. So we're going to add 1 to our window sum. So let's go ahead and erase that and change this to 1. And we're not going to do this because, of course, this didn't resolve to true. So we're going to go back to the top of our loop here, and let's actually write out what indexes we're on for these loops. So for I, we're now on index 0, and for j, we just did index 0, so we're now on index 1, because j just incremented after we added to our window sum here. So for j, we're at index 1. So once again, we're going to add to our window sum I plus j. So our I is 0 and our j is 1, so 0 plus 1 is 1, so we're going to add the value at this index here. So 1 plus 12 is 13, so our new window sum is going to be 13 here. And once again, we're not going to need to do this, so we'll arrive back at the top of our inner for loop here. This is going to become 2, it's going to increment to 2. And once again, we're going to add to our window sum I plus j. So 0 plus 2, which is going to be index 2. So we're going to add the value at index 2, which is negative 5. So we can go ahead and erase this, and the new value becomes 8, because 13 minus 5 is 8. And once again, we'll end up back at the top of this inner for loop. We will increment to 3, and then we're going to add I plus j to our window sum again. So I is 0, j is 3, so 0 plus 3 is going to be this value here, negative 6. So we're going to add negative 6 to our window sum, which is going to leave us with 2, because we're subtracting 6 from 8. So we're left with 2. And at this point, when we get to the top up here, and we increment our j to 4, that means that j is no longer less than k. It's now equal to k because k is 4. So we're going to terminate this for loop, and we're going to end up down here. And down here, we're just going to check if our window sum is 0, which it's not. Our window sum is 2. So if our window sum is not 0, we're going to calculate our max. And we're going to do that by taking whichever is greater, our current max, which is currently negative infinity, or our window sum divided by k, and k is 4. And our window sum is 2. So 2 divided by 4 is going to equal 0.5. So we're going to take whichever is greater, 0.5 or max. And 0.5 is definitely greater than negative infinity. So our new max is going to become 0.5. So we can go ahead and write that out here. Max equals 0.5. It's no longer negative infinity. And we can just erase this. So once we have our new max, we're still in this top level for loop here. So we can go back up to this top level for loop, and we're going to increment our I. So our I is going to become 1. And our window sum is going to go back to 0. And this inner for loop, our j is also going to go back to 0 because it's going to reset. And now we're going to check this again. So is 1 plus 3 greater than the length of our nums array minus 1? So is 4 greater than 5? No, it is not. So we can go ahead and start adding to our window sum. So let's go ahead and move this as well because we're on index 1 now. And we're going to add the value at index I plus j. So 1 plus j, which is 0. So we're going to add the value at index 1. So this is going to become 12. And we're not going to do this. We're going to end up back at the top and we'll increment this inner for loop again. And once again, we're going to end up here. So we're going to add the value at index I plus j to window sum. So we're at index 1 of our top level for loop, plus we're at index 1 of j as well. So we're going to have an index of 2. And we're going to add the value at index 2, which is -5. So 12 plus -5, or 12 minus 5, is just going to be 7. And once again, we won't do this, and we'll be back at the top here, and this will become 2. And then we'll add I plus j to window sum once again. So 1 plus 2 is going to be 3. So we're going to add this -6 to our window sum, which is going to leave us with 1. And we won't do this, and we'll end up back at the top here, and j is incremented to 3. And then we add the value at I plus j. I is 1 plus 3 is 4. So at index 4, we're going to take the value 50 and add it to our window sum. And that's going to leave us with 51. And we won't do this, and we'll end up back here, and j is going to become 4. And once j becomes 4, we're going to terminate this loop because this loop only runs if j is less than k, which is 4. So we'll just go ahead and erase that, and it's 4 now. So this loop gets terminated, so we end up down here. Window sum is 51, so it's not 0. So we're going to calculate our max. So we're going to compare the max 0.5 with our window sum divided by k. So 51 divided by k. Or sorry, 51 divided by 4 because k is 4. And that's going to come out to 12.75. And 12.75 is greater than our current maximum of 0.5. So we're going to replace this current maximum with 12.75. And then once again, we move up to the top of our for loop here. And our I is now going to be equal to 2. So let's erase this. And let's add the dot back there. And let's also erase this and move it up to 2. And we can also erase this. So our window sum is going to go back to 0. And again, I apologize for calling this window sum. I just want to reiterate that we're not yet using the sliding window pattern. So once again, we're going to arrive at this inner for loop. And it will have reset, so this is going to be 0. And then once again, we're going to arrive here. And our I is 2 plus 3 is 5. Is 5 greater than 5? No, it's not. So we're still going to start adding the subarray values to our window sum, starting with I plus j, which is 2 plus 0, which is going to be index 2. So we're going to start by adding -5 to window sum, which makes window sum -5. And then back to the top of the loop here, we increment j. So j is now 1. And once again, we end up here. So 2 plus 1 is index 3. The value at index 3 is -6. So we'll add -6 to our window sum, which is going to leave us with -11. And once again, we get back up to the top of the loop and we increment j. So j is now 2. And we'll end up here. So 2 plus 2 is index 4, and the value at index 4 is 50. So we'll add 50. So we'll add 50 to our window sum, which leaves us with 39. Then back to the top once again, increment our j to 3, And we'll end up here again. 2 plus 3 is going to give us index 5. And index 5 has a value of 3, which we add to our window sum as well, which gives us 42. And then back to the top of this inner for loop, we increment j. J becomes 4. J is no longer less than k, it's now equal to k, so we're done with this inner for loop. We'll end up back down here once again. And our current max is 12.75, so we're comparing 12.75 with our window size divided by k. Our window size is 42, k is 4. 42 divided by 4 is 10.5. 12.75 is still greater than 10.5, so our max will remain the same. And then once again, we will end up at our top level for loop, and our I will increment to 3. And our window sum goes back to 0. And we end up back at the top of our inner for loop, and j is going to go back to 0. And then we arrive at this line of code once again. So let's go ahead and move this as well. This is going to be 3 now. So 3 plus 3 is going to be equal to 6, which is greater than the length of nums minus 1. So 6 is greater than 5. So we're not going to do this code anymore. So we're going to actually do this code here now. So we're going to set our I equal to the length of nums. So this is going to change to 6 because the length of nums is 6. 1, 2, 3, 4, 5, 6. And this for loop is only going to run if I is less than the length of nums. So this for loop will be done. And also we're going to set j equal to k. J is currently 0. We're going to change it to 4. And this inner for loop is only going to run while j is less than k, while j is less than 4, but j is currently equal to 4. So this inner for loop will terminate as well. And the last thing that we're going to do before leaving this top level for loop is we're going to check if window sum is not equal to 0. So if window sum is not equal to 0, we'll do this, but window sum is equal to 0 now. It's still 0, so we're not going to do this code here. And that means we leave this for loop here, and we end up down here. And if max is equal to negative infinity, we'll return 0, but it's not. Max is equal to 12.75. So we're just going to return max. So we're going to return 12.75, which will be the maximum average when considering all contiguous subarrays of size 4 within this nums array. Now let's briefly go over the time complexity of this particular implementation. So if you've noticed, for every index of nums, so we'll say nums is our in, so we have our big O of in. So for every index of nums, we had to iterate k elements as well. So our time complexity is going to be O of in times k. And what that's going to look like is, it's going to look like this. We have nums here, and let's just put the indexes 0, 1, 2, 3, 4, 5. So for each one of these, we iterated up until k elements. So for example, at 0, to get to the subarray of size 4, we started at this top level for loop at 0, and then in this inner for loop, we iterate up until k elements to calculate the average for a subarray of size 4. So at 0, we touched index 1, 2, and 3. And at index 1 of nums, we touched 2, 3, and 4. And at index 2 of nums, we touched 3, 4, and 5. And even though beyond index 2 at index 3, we couldn't continue, so we terminated things, since this is big O, we don't need to take those details into consideration. So we can still consider this O of n times k. And by n times k, I mean n times k. And when looking at this, you can get an idea of the inefficiency by seeing the amount of times we process the same indexes. So let's see if we can come up with a better solution to how to solve this problem. So at this point, I can now introduce you all to the sliding window solution. So we now know that the naive solution is not ideal because we had to unnecessarily iterate through elements that we've already seen before when iterating through k for each element of nums. The way that the sliding window solves an issue like this for this problem in particular is by, instead of adding up the sum for every element of k again and again for each index of nums, we keep track of the first sum that was calculated and just subtract the value that's at the starting index of the window and add the value at the index after the current end of the window. This simulates moving the window up. For this to work, we will need to keep track of two indexes, the index at the start of our window and the index at the end of our window. From there, it's just a matter of calculating the average for the window and then just incrementing the start and end indexes and updating our sum variable. So let's take some time to code up the algorithm to make this work. Okay, so we are now back in our YouTube patterns directory. And just to reduce the amount of typing that needs to be done, I'm just going to go ahead and copy all of the code from our naive solution into a new file that we'll just call max average subarray I. And now we should have a new file that we can open up that contains all of the contents of the bad max average subarray file. And the reason we're doing this is because we still want to keep this main function. The only thing that we are going to change actually is the function for find max average. So we can go ahead and just delete everything inside of this function. And since our naive solution is part of the same package, we're going to have to actually rename this function. So we can name this function find max average sliding window. And we're going to have to go ahead and do the same thing here. And other than that, everything else is the same. We're still going to have the same input parameters, and we're still going to print our answer here. So now we can just start writing the algorithm for the sliding window solution within this function. So of course, we're going to start with a variable for our window sum, which is going to be an int. And we will also create a variable for our start, which is going to be the start of our window, which is also going to be an int. And we're going to initialize our max as -infinity, just like before. And from here, we're just going to simply create a for loop, and the variable that we're going to use for the index of this for loop is going to be end, because this is going to be representative of the end of our window. So we're going to start it at 0, and while end is less than the length of nums, we're going to increment end. And within this for loop, the very first thing that we're going to do is we're going to add to our window sum the value at end in our nums array. So essentially what this is doing is our end starts at the first index of the nums array. So our end would start here at 8860. And we basically just want to add each value at each index up until we reach the subarray size of k, or the window size of k. So once we get to this point, we want to stop adding the values to our window sum, because at that point we already have our window size or subarray size of k. And the way that we're going to stop it once we reach the window size is we're going to do if end minus start plus 1 equals k, then we will calculate average for the window. And all this is doing, this end minus start plus 1, is getting the current window size. So we can get the window size by subtracting start from our end and then adding 1. And I will go over how that's working once we get to the point where we try to visualize this code. So once we get to the point where our window sum is the sum of all of the elements within a window of size k, we're going to go ahead and calculate our max. And we're going to do that by doing math.max just like before, and we're going to compare the max, the current max, with a float 64 window sum divided by float 64k, just like before. And once we calculate the average for this window, this current window that we're on, we want to move on to the next window because we're done with this window at this point. So that's when we're going to subtract from our current window sum the value at the start of our window. And then we're going to increment our start, just like in the illustration. And we're going to keep doing this until we reach the end of the array. And by that time, our max should be the maximum average for all contiguous subarrays of size 4. So we'll just return our max. So let's go ahead and save this and see if it's working as expected. We can clear, and then we'll go run max average subarray I.go. Actually, I'm sorry, I'm using the wrong input array for this. And also I forgot that this is part of the same package as our last solution. So we're redeclaring the func main as our entry point in this one as well. So let's go back into this old one. You know what, I'm just going to comment this out. And back into max average subarray. And let's just go back to the problem online and take this and put it back in our nums array and change this to 4. I'm sorry about that. I'm not sure when I actually tested out that other input, but in your file, in your bad max average subarray.go file, these inputs for you should still be 4 and the input array from the actual problem example. At some point I was testing out another input, I just don't remember when. So let's go back into here. So our main function should have k equal to 4 and it should have nums equal to this array of integers from the example of the Leetcode problem. Let's go ahead and clear this and then go run max average subarray.go. And as expected, we get 12.75, same as the old solution, the naive solution. So now let's take some time to go over this code. Okay, so let's take some time to go over this code. So we'll start by writing out our nums input. And we're going to use the same input as with our naive solution. And k will be 4 still. And we're going to start with our window sum being equal to 0, and our starting index is going to be equal to 0 as well. And remember, for this solution to work, we need to keep track of both the start of our window and the end of our window. And our max is once again going to be set equal to -infinity for the same reasons as explained before. And we're going to simply arrive at this for loop here. And we're going to refer to every index of this for loop as our end. So as we're iterating through this array, every iteration is going to be the end of our window. So our end will start here, and then it'll move here, and then it'll move here, and then here, and so on and so forth. So we will start at index 0 and build our window up to the size k. So we'll arrive at this line here, where we're going to add to our window sum the value at end. So let's go ahead and play this out. So we'll start at this for loop. Our end is going to be 0 in the beginning, and our start is also going to be 0. So we'll just have 0 for start. Our window sum is going to be 0 as well. So we start here at index 0. So we're starting here. And we're going to add the value at this index to our window sum. So we'll add 1 to the window sum. So window sum plus 1. And once we add this value to our window sum, we're going to end up here. And it's going to check to see if our window size, this here calculates our window size, our current window size, is equal to k yet. And if our current window size is not yet equal to k, then we're not going to do this code. We're just going to continue back up to the top of the for loop and continue to add the values at the indexes. And we can see that end minus start plus 1 gives us our current window size because our current end is 0 and our current start is 0. So 0 minus 0 is 0 plus 1 gives us a window size of 1. And the same would be true if our end were here and our start were here. We would do index 2 minus index 0 plus 1, which would be 3, which would be the size of that window. So as you can see, this little formula here calculates our current window size based on our start and our end. So the reason we're not doing any code in here until our window size equals k is because, of course, we want to calculate the maximum average for window size of k. So until we get to the window size of k, we don't want to calculate the average. We just want to keep adding the value to our window sum. So that's why here we're at index 0, we add the value 1 to our window sum, and we don't do this code. We just move back up to the top of the for loop, and now we're at index 1. And once again, we're going to add the value at our end. Our current end is 1, so we're going to add 12 to our window sum. And once again, our current window size is not equal to k. Because our current end, let's actually just write this out. So this is our end, and this is our current start. Because as you can see here, we haven't done anything with our start yet, so it's still 0. And our end is moving up as we increment our for loop. And we have not yet reached our desired window size, because our current window size is only 2 elements. Because end minus start, so 1 minus 0 plus 1 is 2. So our window size currently is size 2, but we want a window size of 4, right? So we're not going to do this again. We're going to end up back at the top of our loop, and we're going to move our end up from 1 to 2, index 2. So we can erase our end here, and our end is now here. And once again, we'll add the value at our end to our window sum. So the value is -5, we'll add it to our window sum. So we'll do plus -5. And once again, we'll check to see if our window size is the size of k. It's not. Our window size is 3. So we're going to skip this code again, move back to the top of the loop, and increment our end once again. So our end is now index 3. And we'll add the value at our end to our window sum. So we'll add -6 to our window sum. And at this point, we're going to arrive here, and our window size is equal to k now, because end minus start. So our end is index 3, and our start is index 0. So 3 minus 0 is 3, plus 1 equals 4, which is our value for k, which is the desired window size. And if you see, we have 1, 2, 3, 4 elements between our start and end. So that means we'll go into this code to calculate the average. And to calculate the average, we're just going to simply divide our window sum by k by 4. So our current window sum, let's go ahead and resolve this. So 0 plus 1 plus 12 minus 5 minus 6 is going to equal 2. So let's erase this and go ahead and write 2. So our current window sum is 2. So we're going to divide 2 by k, which is 4. So we're going to divide 2 by 4, which is going to be 0.5. And our current max is -infinity. 0.5 is greater than -infinity, so our new max is going to become 0.5. And here, just like in the illustration, we're going to subtract the value at the start of our window. So we're going to subtract 1 from our window sum, and then we're going to increment our start. So we'll subtract 1, and then we'll get 1. So our window sum is now 1. And we're going to move our start up 1 index. And then we're going to go back to the top of our for loop here, and we're also going to increment our end, just like in our illustration. So the end is going to move to 50. And just like in the illustration, we're going to add to our window sum the value at our end, which is 50. So we're going to add 50 here to our window sum. So plus 50, and actually let's just write this out as 51. So our window sum is now 51. And then we'll end up here again. And at this point, our window size is 4 again. So 1, 2, 3, 4. So we can go ahead and once again go into the code here. And this is no longer true. So now we're going to take our window sum 51 and divide it by 4. And that's going to be 12.75. And we're going to check which is greater, our current max or 12.75. 12.75 is greater than our current max of 0.5. So our current max is going to change to 12.75. So we can erase this. This becomes 12.75, and we can erase that too. And once again, we're going to subtract the value at our start from our window sum. So the value at start is 12, so we'll subtract it from our window sum. So minus 12 equals 39. And then we're going to increment our start once again. So our start is going to move up to index 2. And then we'll go back to the top of our for loop and we're going to increment our end as well. And we'll add the value at our end to our window sum. So 39 plus the value at our end, which is 3. 39 plus 3 is going to be 42. So our new window sum will be 42, and our window size is equal to K4, so we're once again going to calculate our max. So our current window sum is 42, so 42 divided by 4 equals 10.5. And our current max is 12.75, which is greater than 10.5, so we're going to leave our max as 12.75. And we can erase this. And once again, we'll subtract our start value from our window sum. So we'll subtract 5 from our window sum. And we'll get 37. Then we'll go and increment our start. And then we'll head back to the top of our for loop here. And at this point, our end is no longer less than the length of nums, so we're not going to do anything else in this for loop. So we'll go down to this return max here, and our max is 12.75, which is what will get returned. Now, as you can see with this solution, we didn't need to unnecessarily iterate through indexes that we already iterated through. So instead of our solution being O of n times k, this solution is actually big O of n. And the reason for that is because this for loop is going to iterate through every element of n, right? So that's O of n, right? Because it's going to scale linearly with the size of n. But then also we have this start as well. And our start isn't going to touch every element of n. It's essentially going to touch every element of n minus the window size. So it's going to look something like this. So we have O of n plus n. So let's imagine that this n is our end here that touches every single element of our nums array, right? And then we have our start here that also touches almost every element of our nums array. But it's not going to touch n elements. It's going to touch something like n minus k minus 2 elements, somewhere around there. So if our start only gets to index 3, that means it's only touching 4 out of 6 elements. There's 6 elements in this array, so our n is 6 here, but our start only touches 4 of them. So if we go ahead and plug these numbers in here, we'll get 6 plus 6 minus 4 minus 2. 4 minus 2 is 2, so 6 minus 2. 6 minus 2 is 4, plus this 6 will bring it down. And then this is going to equal 10. So our end touches 1, 2, 3, 4, 5, 6 elements. And then our start touches 7, 8, 9, 10 elements. So if we were to just write it out, you'll kind of see what I mean by this n minus k minus 2. But of course, since this is big O, we ignore constants. So we actually don't even need to consider any of this because they're all constant. So we really only need to pay attention to O of n. So the complexity is big O of n, which is a pretty substantial improvement from our naive solution. So that is going to be it for my explanation of the fixed window size variant of the sliding window pattern. In the next video, we're going to continue with the sliding window pattern, this time using an example of a dynamically sized window variant of the sliding window pattern. And although this initial explanation used a Leetcode problem that isn't in the Leetcode patterns list, the following videos for the sliding window pattern are going to be explanations of problems that are actually in the Leetcode patterns list. Anyways, I hope this video was informative, and please don't forget to like and subscribe if you aren't already subscribed, and I'll see you in the next one.